Hello and welcome to Game Titan. In the last video, we talked about why this code rendering the two-dimensional array of either blue or gray squares was slow, and how to use the FPS counter that we had previously built to figure out which of the code was exactly slow. We could keep optimizing the code to try to make it faster. However, if we do that, we are actually going to run into a much bigger problem, which is that Scratch has only a certain number of clones available to be on the screen at the same time. So, for example, if we change these numbers to, let's say, 20 and 20 and run the program, we will see that we didn't actually get a 20 by 20 array of clones here. We got much less than that. And we could, for example, say that this is going to be 20 by 50, and you can see that there are far fewer than that here. In fact, you can count the rows. There's 6 rows of 50, which corresponds to Scratch's 300 clone limit. As you can also see, the number of times that the costume updates are happening per second is very low. Actually only 2 per second, so this type of performance is not going to be suitable for doing some kind of graphical display of pixels that animates quickly. There is, however, a different block in Scratch called Stamp. It's in the special menu that you need to add here, this extension menu called Pen. So to get to it, you can click this blue button down here in the lower left corner, and it will allow you to add some extension blocks to your project. You can click Pen, and in here there's a block called Stamp, which takes the way that your block looks in its current position and stamps it onto the background temporarily until Erase All is later on called, at which point all the stamps are erased, along with all of the other pen marks that you might have made with these other blocks. So instead of creating an array of clones and having them update their costumes over time, what we could try to do instead to make this faster is have the single object, single button sprite, move around the grid and stamp itself over and over again in a grid shape. So to do this, we will likely need to update. We can get rid of this code that we're playing around with before. We can likely update this tick function right now, which says update grid contents, and instead we'll have it call a different function that we'll create, that we'll call Stamp Grid. We definitely want to run this without screen refresh, because it will be stamping many times and we'll need to see if it's fast enough, and we don't want each stamp to take 1/30th of a second. So we should have this tick function call Stamp Grid repeatedly. We can make sure that that works. You can see that the clones are still created, and that's because up here in initialize, we're still calling initialize grid. So we don't actually want that to happen. Separately from that, we have these adjust clones and dirty bit functions. And actually, initialize grid may have actually been to initialize the array. So let's try to find that. Here, and this actually just initializes the array, so we can move this function further up so it's closer to and above where it's called without attaching it accidentally to that block. And then here we can put initialize grid back in. We can check to see that grid did actually get initialized. It looks like it did. It's at 1,000 long, which corresponds to 50 wide, 50 columns and 20 rows. Now that we have this list, we need to implement stamp grid. So the way to do this is we're going to have two loops. One loop is going to look at a row, use this row variable, temporary row variable to loop through, and the other loop is going to loop through the columns. So the outer loop is going to loop one time for each row. The first time through the outer loop is going to be the first row. The second time through the outer loop is going to be the second row, etc. And the inner loop, while it's processing the first row, is going to have its first time through the loop be the upper left cell in the first column, and the second time through the loop will be the second cell over to the right, and the third time through the loop will be the third cell over to the right, etc. So this loop will have to first initialize row, which is here, to 1, and then we will say repeat until, and we want to check until row is greater than the number of rows. Which, if we look in our other code, is set in current rows, and the current number of columns is set in current columns. Although we just detached adjust clones. Over here, we had detached this from being called, so that's not actually going to be the case. Instead, we can use target rows and target columns. So once row is greater than target rows, then we don't want to run this anymore. And then now that we're on the first row, so this will say do row 1, and then do row 2, and do row 3 up until we get to the last row. It'll do that one, and then when it gets one larger than that, it'll stop. So inside of that, you'll set the column that we're doing to 1, and then we'll have another repeat until block. And then similarly, you'll say if the column is greater than the target number of columns, that will be when you stop. And inside here, what we need to do is move the block to a certain spot. We'll say go to X and Y, and then we will change the costume to be the appropriate costume, which we can take this code here. So we're looking at some index, some item number in the grid, and we want to switch the costume to that value plus 1. So grid, this is saying that if the grid value is 0, we'll use costume 1, and if the grid value is 1, we'll use costume 2. The reason for that is because this first costume is costume 1 and this costume is costume 2. So we'll say go to X, switch the costume to that value, and then we will call stamp. there's two things remaining. One is to figure out what X and Y are, and the other one is to figure out which item number we should get. I think that the easiest way to get the item number would be to use another variable, although you could calculate it from row and column. But we'll set this value I to 1 and then change it every time through the loop. We'll add 1. So the first time this runs, I will be 1, and then it'll get changed as we move on to the next column, and the second time through this loop it'll be 2, and so on, and we'll never actually reset it. So in that way we'll go all the way through the different elements in the grid. That way we can get item I out of the grid. That actually is a good point, that right now call and row are also not changing. So here we also need to increase call by 1, and after all of the columns are done, which is over here, we'll need to change row by 1. Otherwise this loop will run forever. So now all we need to do is figure out where X and Y are. So X is going to be some number in the upper left plus some number times the number of columns. So the first column has the smallest column number 1, and the second column has the second smallest column number 2, and they keep increasing to the right. And similarly, X also increases as you move to the right. But you don't want each stamp to be 1 pixel apart from each other. You need to multiply call by some amount in order to get the stamps to be a little bit more separated from each other. So we'll drag this in, and there should have been a spacing value from before, and we can copy call over here like this, and then we can say X is going to be that. Y is a little bit more challenging. So the first row is on the top, the second row is on a little bit below that, the third row is below that, etc. So as row increases, we get further and further down the screen. However, with the y-axis, as y increases, we are actually getting further up and up the screen. And so what we need to do is take the negative value of call, and that's going to be -1, -2, -3. So if we just plug this in right now, this time spacing, we would end up with the first, excuse me, I didn't mean column, I meant row. We would end up with the first row in the middle of the screen where y equals 0, etc. And so we need to take all of those values of -1, -2, -3 going down the screen like that, and add some amount to that. So that we can plug in here. I can stick 0 in for now just to see what that looks like. And then similarly to the column numbers, we will also have to multiply that by spacing so that the stamps are not 1 pixel apart from each other. So we'll stick that in here and we'll see what we have. There, we can see that that did stamp, and that we did not shift this up any. So for example, we can just do this by trial and error. If we did 50, let's see, this stamp is not ever getting cleared. So there's one other thing that we'll need to do when we initialize, is that we'll want to clear everything out. And now we can see that it's clearing each time. So if we add 50 to this y value, for example. So you can see that's actually shifting up already. This is not actually what we want, because this is moving before we multiply by spacing instead of afterward. So we will take this value here and then add some extra amount to it to shift the y value further up. Like that. And then if we increase this, you can see that even though it's not clearing, it's moving further up the screen. And then similarly here, we'll also need to add some, amount. In this case, we'll actually need to subtract some amount. So we can do that by adding some negative value, maybe minus 240. And now we can see that this grid is rendering. This grid is also rendering every tick. So here we have this update grid contents, and if we add that to tick, then we can see that the grid actually is updating, and that we're actually receiving 30 frames per second, even with this larger number of clones, with this larger number of stamps. Compared to the clones, this is way more clones than this is way more stamps than the number of clones that were possible. And it's already rendering many more times per second than the clones were. Potentially, we could increase this to fill up the whole screen, which was sort of what my goal was in the first place. So if instead of 20 rows we said 50 rows, that actually looks pretty good. Maybe 35. Play around until we find the correct amount that fits on the screen. It's a little bit less than 40 right now. Let's hide this grid variable. And we can hide the debuggers for these two. And you can see that we aren't quite getting 30 frames per second anymore, so we're starting to run into the limits of what Scratch can do on this computer. But that said, we are getting much better performance than before, and this should certainly be fast enough to render something interactive and have it look pretty good, even though it's not quite 30 frames per second. If you found this interesting or helpful, please like this video and subscribe to the YouTube channel, and leave a comment. If you use any of this techniques in any of your projects, please leave a comment with the link, and I'd love to take a look at it. Thank you for watching, and see you next time.